So I've poked around at the kernel devices and seen various files the kernel provides, both for accessing hardware and some purely software stuff. And now I'm going to start applying this over the network. So there are several scripts that help with this, but they mostly use this program called Exportfs. So Exportfs provides a file descriptor to a remote machine that lets the remote machine do things to the files, but that ultimately results in those 9p requests coming back to the machine serving Exportfs. So let's see here, man, rcpu. rcpu, rimport, and rexport use Exportfs. So in the case of rcpu, it gives the illusion of logging into a remote system. What it really does is export the console of the system I'm sitting at, the console input, output, and error to the remote CPU server. So let's go ahead and start looking at those. That'll be an RC bin. Oops. So our CPU's here. If we go down here, we can see that, it's going to be running this Exportfs and the rconnect to sort of send a command to the remote machine to start doing that. So the remote rimport does a similar sort of thing. It tells the remote system to Exportfs part of its namespace to, the machine I'd be sitting at. It then gets posted into serve, /srv, and then mounts it in my namespace in a place I tell it to. And, the export one sort of does it in reverse. So you can see where you can put in, your host, your tree, and various other little options in there. Let's run these and actually see what happens. I'll start with some new windows. So I'm running on a terminal here. And this is what the default namespace for it currently looks like. And I'll open another window and use rcpu to connect to a CPU server. So now if I look at the namespace, there's going to be a change here at the bottom. So it's going to be doing this little mount here into a new directory called mount term, and then mounting the dev console of that, or binding it. And since there's no letter, it's just going to be completely replacing it for the dev cons and the console control, along with adding in afterwards some various other devices. So if we check the processes running on the terminal, versus this one over here, we see the terminal is going to be running Exportfs, and it's basically going to be sharing everything from, / the root directory. So it's exporting everything over to Beefcake here. And on this end, we can see that it's listening and getting a connection from, this is going to be the IP address for the video Pi. And we can see actually that this listen is where that PS tree is even running at. Let's see here. All right. So basically, if we want to look into it, we now have that new directory here in mount term. If we look in there, we see an entire, what you'd see in the entire root, and this is actually the whole thing being sent over from the video Pi, and so all the reads and writes of the console are coming out from the dev directory in here. So if we go and actually look in dev, so we're in mount term dev. If we read the sysname out of this file, it's going to report back that it's VideoPi. But if we cat just the dev sysname, this will be reporting back from Beefcake. So next up, I'll do rimport. So get another window going. So I have a my LabPi set up. It has an SCD40 sensor hooked to it. And so now I'll import that into the window on the terminal here. So run rimport from LabPi. This is where it is in the namespace of the LabPi, and I'll put it into my /n. All right, no news is good news, so we should get, oh yeah, we don't get anything on serve on this one. But if I go to n now, I can see that there's the stuff from the SCD40 sensor. And if I look at the namespace, we can see we got sort of more connections going on again. So let's see our processes. So yeah, we still got that one there. This would actually be running on the LabPi. So if I go look at LabPi, let's log into that one. And we see what it's doing. We can see here where it's being asked to Exportfs SCD40. So, and yeah, we got another connection there. And the opposite of the rimport is rexport. To export to another system, it has to be listening for commands. As I covered before in the termrc and cpu-rc boot scripts, terminals don't run listeners at boot, so I can't really send anything to the VideoPi terminal here. So I'm going to export from one CPU server to another. I'll send the SCD40 sensor from the LabPi over to Beefcake. So I'll export. I'll give it a name for that'll be used when it's posted into the /serve directory. I'll call it CO2. I'll be using this directory as CD40, and I'll be sending it to Beefcake. So in this case, I'm not going to try and put it directly into namespace on Beefcake. Instead, I'm just going to use that S flag to post it in the serve directory over here. So if I look now in serve, there is an entry for the CO2 device. So you notice that LabPi didn't return back from the prompt. That's because it's running this process to maintain the open channel. So over on Beefcake, I can see the new listing in serve, and so I can now mount it. So let's mount serve CO2 to N. If I go to the N directory and see what's there, I now have all my sensor data here too. So in order to close the export FS that's running, I have to sort of meet two conditions. First, I have to get rid of that serve entry because that's holding open a file descriptor. So, and you can just easily do that by just saying remove CO2. But that didn't close it yet because I still have now an open descriptor that I'm still using to, you know, read here in /n, because I can see in my namespace, it's still reading it. So if I go ahead and exit this here, which will kill the process running on Beefcake, that closes out any file descriptors it was running, and my prompt came back. So you have to remember both the serve has to be closed or removed, so that removes one opening, and then any other process also has to finish up before it returns. And you'll find that a lot throughout the system. It checks to make sure that, before it actually deletes something, that no processes are currently holding that file descriptor open. Oh, and this stuff works also just for the kernel devices. It doesn't have to be stuff explicitly set up in the namespace of the server you're pulling from. So I'll do a demo I've done a few times, and maybe now it'll sort of make a little bit more sense what's going on in the background. So I'm going to import from before, from Beefcake, the audio device. So I'm using the kernel file here now, into my dev. So now if I look in dev, let's go -l. I should see an audio device, which normally wouldn't be there because I'm running on a Raspberry Pi and we don't have audio drivers for the Pi because it's kind of crappy. Anyway, so now if I do something like run Doom, I can get the audio to play out of a separate computer. I don't know if I have the volume up high enough. Oh, there we go. So now you can get an idea of, like, when I do this sort of demo, like what's really kind of going on in the background. So in this case, I sent a command over to Beefcake to use Exportfs to send over its audio device, and then I can put it in my namespace. And then when the program runs, it just sees dev audio. That's all the program does is it just opens up, looks for a file called dev audio and writes the audio into it. Doesn't really care where it's at. All that sort of piping over to the other computer happens in the background. So hopefully this sheds some light on how files and namespaces can be shared across the grid. Also have a video next on how to sort of how to expand on this and start serving more and more services across the network. And as always, have fun.